Start recording. All right. So we're on part 2 of functions today. We're going to talk about the solution to project 1. We'll do that first. And I'm actually going to solve it with functions. May or may not be interesting to you. You didn't have to use functions at all. Again, there's not really anything functions let us do that we couldn't have done before. They just give us another tool here. So again, we can avoid repeated code and not feel bad about ourselves. And almost more importantly than that, we can put a name to what's happening. So we can just see, hey, this is what this couple lines of code is called. This is what it does. And we can kind of take a problem and break it down, do that functional decomposition and say, okay, I'm going to do this step, and then I'll do this step, and then I'll do this step. And it gets to be a lot of fun. So let me fire up Visual Studio here. I'll start a new project. Everybody got it in, right? I think I worked through most of the questions. I don't think anyone else had emailed me yet this morning, last I looked. So I'll make a new project here. Again, I'll just do the console app so I get some garbage and I'll throw that garbage away, but it's fun. So this is project 1. And again, I'm putting it in my course GitHub repository. You would put it in your project 1. I think people are getting finally a little bit more comfortable with that. It'll take a little bit longer to get used to it. It's all new. It's a bunch of steps, but that's okay. A little old-fashioned. People used to put comments in like these sorts of things. We have source control tools now. You don't need to tell me this sort of detail. People used to say like, hey, the author was Eric Chernesky, and the date last modified was and this sort of stuff is worthless because you can see all of that in source control. I can go to GitHub. Oh my goodness, I can't even type. Did I show you like Microsoft's account? Microsoft. They've got a bunch of things they're open sourcing, which is really cool. I'm pretty happy. So like VS Code, if you want to see the code for VS Code, you can come in here and see. So let's find, I don't know, here's the source code here, and then we'll find something in VS, and how about the editor and the editor API TS? Sure. If you want to see something in the details here, this was last changed by whoever this Alex Dima person is 8 months ago. They were the last person to touch this file. If I want to see, hey, who changed each individual line? Like I see, hey, there's an error, I'm getting a bug, it's throwing an exception at line 17 or something here. I can go through and hit blame. It'll show me the last time each line was changed here. So 8 months ago, he changed this section here. 5 years, so a lot of this hasn't changed for years, right? So you can see all of that is tracked in the source control tool. I don't need to put comments in the files here. So again, I just think comments are a big waste of time because we have tools for that sort of thing now. Okay, so namespace standard. We don't need any of this stuff. Okay, so we got main. Eventually we'll return a 0. We don't need this because we added the standard thing. And again, I just like end lines, endls. I don't know. That's just my preference. Okay. All right, so now we're good to start working on the project here. So let me come back over here and pull this up. And we want to take a second before we actually write any code. We want to take a second and see what are the steps we could break this into. Right? Just kind of think through it. We don't. If you jump right into writing code, it's going to be a big jumbled mess. Right? You have to have a plan for what we're writing. Right? Even if we didn't use functions at all, we have to understand. Okay, I need these things first, and then I need these things, and then I need these things, and then this will happen. It's like we have to be able to understand it well enough to break it down to tell the computer what to do. So, okay, distance to surface, we've got X and Y tilts. This one feels like a really quick win for a function. If you have 2 different values that are both going to get a number between -10 and 10, you're doing the same thing twice. So that should be a quick little flag in your head. Hey, I have to do the same thing twice, I can use a function. And you're not really saving a whole lot of code because that's really easy to copy paste, but that's a great opportunity for a function. So why don't we start with that one? So we'll write a function and it's going to return an integer, right? If I'm going to get a number back, it's not a void function, it's an int because I'm going to return something here. So we get random value -10 to 10. Sure, why not? That's really big, but sure, that's perfectly fine. No big deal here. So we can do the math here then. So when I get a random value, right, if I want it to be a new looking random sequence every time, we have to use that srand thing here. So we can include ctime here, and you can say, hey, I want to seed the random number generator with time of 0. So essentially, every time this runs, it will give it a new starting seed value, and it'll get a new looking sequence of values, random values. And it's not actually random, but that's about as good as we can get here. So I can seed the random number generator, and then in my case, I can just return right away. Right? So I can return, I'm going to take rand. Now, I know there's 21 values in the range, right? Because positive 10 minus negative 10 is 20. But then there's actually the 0, 2. Counting here gets a little bit weird. But essentially, how many numbers are in the range here is going to be 21, right? And then that will give me a number between 0, mod 21. My goodness, mod 21. Will give me a number between 0 and 20, right? Because now I'll get 0 to 20, so I'll have 21 possible values. And if I have 0 to 20 and I want negative 10 to positive 10, I just back it off by 10. Or this direction on your number line, right, in your head. Subtract 10. Right? So you probably did something like this for your random numbers. Awesome. Now, if you wanted to be fancy, but we don't need to right now, this sort of function, we could put in a start and an end value. And we could put that into our formula here, right? Because we're subtracting by the starting value. Really, technically we're adding the starting value, and our starting value would be negative 10. Adding negative 10 is the same as subtracting 10, right? If you want it, we could have arguments here for start value and an int for end value, right? And then we could mod by the start value minus the end value, and then end value somewhere in here plus 1. I forget why. I think that math works out. Like if you want a number 1 to 10, 10 minus 1 is 9. Add 1 more, so you have 10 different values. Something here is probably fine. So mod by that, right? And then you really want to add the ending value, the start value, right? So if we're starting at, that's why we don't need the plus 1 here. Okay, that ought to do it for us, right? Is that going to do it? Something in here ought to work, but again, we don't need to be that fancy, right? We'll just make it easy. Mod 21 minus 10, right? This sort of thing could be useful later, and you could use that in other things when you want random numbers, but again, we'll get there later. Okay, so I can get a random number. So easy. So I can have a int for my x tilt then is going to be my get random number, negative 10 to 10. And I can have an int for a y tilt is going to be a get random number, 10 to 10, negative 10 to 10. Right? And I'll have an int for my distance from surface. I know that starts at 10. Right? And now we get a bunch of commands. Right? If the command doesn't match something that was entered, one of the valid ones, we have to give them the list of valid commands. So this sort of, let's ask them for some input and validate it, can be its own method or its own function, right? That could be one little piece here. So sure, we can do that. We can write a function that returns a string like get valid command. Right? That can be a piece that we do. Let's ask to get a valid command from the user, and we'll give back the string of that valid command, or integers if you wanted to do integers for your inputs. Right? Either way you wanted to do it's fine here. I think I use strings in my example, so I'll stick to strings. Does that make sense? Okay, cool. So to get valid command, we can see out these enter x plus, x minus, y plus, y minus, thrusters, nothing, self-destruct. Now, having spaces in here gets to be really weird when you have cin and getLine. So I'm going to avoid spaces just because I don't want the hassle. Right? When you use getLine and then you use cin doesn't actually get the enter key. So the next time you use getLine, it's like, oh, hey, you entered something, but you just get an empty line. It's a big mess. It's okay to figure out later. Usually you just stick to one, but it's a big hassle. So I'm just going to avoid it here. We'll just say, how about destruct? Or self-destruct, all one word. Like destruct, and nothing. Right? Those are our valid options here. Right? I'm just going to take a shortcut because that's easy. And then I can have a string for their command, right? And I can see in the command. Now I need to loop to make sure they gave me something valid. Right? So again, I don't like having to repeat these sorts of things here. So if I set command to something here that's not one of those, then I can loop here. I can say while my command does not equal x plus, right? Does not equal x plus, and my command does not equal x minus, right? We can go through the list here. It's not this, and it's not this, and it's not this, and it's not this. If it is any of one of those, right, the whole thing will be false because I'm anding together, right? We can use our and logic here. And command does not equal y minus or y plus. Sure, we'll do them in order here, right? And command does not equal y minus, and command does not equal thrusters, and command, we'll go down, command does not equal self-destruct. Oh, we got too many ands here. And command does not equal nothing. Right? If it's not that, and 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 it's not that, we'll ask them to enter some values here. Right? This hangs a little weird. Usually you would want those like in a little further. Again, it's just a preference. But that way you can see this is part of the while block here, or the condition. This is what's actually running inside. We just use that, the visual white space for us people here. That part makes sense? So just a little validation loop, right? Eventually, I'll get out of here, hopefully, I can return the command. It's one of those. Now, having to type these lots of times is bad, right? We've talked about that anytime you have something hard-coded in here, you're likely to typo it, because I typo things all the time. So it might be better to have a bunch of constants, right? And we can do constants at the global level, right? Bless you, they don't have to be inside of functions here, because if you define it inside of one function, it's not accessible in the other function. So we have to go to that bigger scope, which is our global scope here. So I can have a constant string for, I don't know, x plus equals x plus, right? Goodness, nope, I can't use the plus sign, x plus. I'd like to be a little ugly, but that's okay, right? X minus, and so on and so on and so on, right? So we can add these, string y plus, constant string for y minus, constant string for thrusters. Oh, that's right, these should all be uppercase, sorry, x plus because they're constants. So x minus, there we go, that looks better. Y plus, y minus. Thrusters. I think I was doing my typing in all lowercase, right? Thrusters. I always wanted to match. Constant string self-destruct. Self-destruct. And constant string for nothing is a nothing. Right, and then I can use those in here. X plus and x minus. And this is a little bit better here. And again, it might be a little bit more verbose. I've done a little more typing necessarily than I might have needed to, but it's going to help reduce my amount of typos, right? Because I've got these constant values I'm comparing to everywhere in my code rather than the chance that I screwed it up somewhere. So I don't know if any of you had the pleasure of trying to debug and you found out you had a typo somewhere, but I think at least one person I was working with had a typo in thrusters, right? And that's okay, right? That happens. So these sorts of things are just helpful to keep us from running into that. And command is not nothing.
The lab before this.
Okay.
Triangle.
Oh.
I always spelled it wrong.
Triangle. Yeah.
Forever. That was the last comment that I made, was fixing every spelling error.
Nice. Now, someone had the thought like, hey, if I've got the constants, can I use them in my outputs? You can, but then it's going to be kind of ugly. You'll be like, here, enter this, and then you have x plus, and this is a fantastic idea. It's just really annoying. So I love the thought. It's probably a good thing to do. At this point, I'm so sick of typing here that I just don't want to, but that would be good, right? Like, how do I get all those extra spaces in here? What was that? Did I do that? That's super weird. Did you see them? Oh, I think when they got separated, it took all the spaces out because they're like, hey, these must be operators now. That's what that was. Okay. So here's our little validation loop. We can get a valid command. We're very excited. So now we can get a command. We know it's valid. The other piece though, right, if it's not valid, where is it here? Give them the list of valid commands. So I'm sort of giving them at the start here, sure, this satisfies that, right? It was not valid, here's your list of valid commands, right? You could be more, you could just say get enter command and then have them guess, and then when they guess wrong, tell them what they are. That's probably not as friendly, but that's an option, right? That's one way to satisfy it, and that's okay. So sure, so we can get a command here. And now really, all of this happens as long as our distance is not 0. Right? Sort of in this loop here of until we hit the surface. Right? So sure, we can do that. If we wanted to, we could even put that in its own function. There's nothing that says we can't here. So and again, there's lots of different ways to make functions. There's not necessarily one right way or one wrong way. So that's okay. So maybe we'll call this the, I don't know, this could be void, right? Maybe it's not going to return anything here. This will be, I don't know, get lander to surface. Sure. And to get the lander to the surface, we could pass the x and y tilts if we wanted. X tilt and an int for the y tilt. If you wanted to, this function could also just set them itself here. Right? If you want to hand them to the function, great. If the function wants to get them itself, that's okay too. Right? Both ways will get it a value here. I just want to give you a couple different examples. This one will take some parameters, which is kind of fun. So I can say, we'll just get the lander to the surface, given my x tilt and my y tilt. X tilt and y tilt. Right? And maybe then my distance from surface, I set inside of here. Right? I can say, okay, to get the lander to the surface, let's start at 10. And we can say, while my distance to the surface is greater than 0, let's keep on going. Right? We can do it all inside of this function here. So main just says, hey, here's an x tilt, here's a y tilt, get to the surface. Right? We know there'll be a play again here, right? There's a while string for play again equals a y, and while play again equals a y, right? Or play again, sure, equals a uppercase y. I guess we could do lowercase. We can lower it here. How about lower, or too lower? It's too lower, isn't it? Without the camel casing, that's super weird. Oh, I hate this, I'm sorry. It's not a character, I can't lowercase a string. C++ is dumb. I'll just leave it this, that's okay. I'll be lazy. And then we can see out, do you want to play again? You want to play again. And then we can see in, we should tell them, right, y or n. And we can see in on play again. All right, cool. So now I've got my game loop here, right? Play again starts. It's true, I know it runs. Just to avoid the do loop, because I hate do loops. I think they're stupid. Set my tilts, pass them to the lander, get lander to the surface method function, ask them if they want to play again. So everything's kind of happening inside of the get lander to surface function. That's okay, we've moved it now. Excuse me. So while the distance is greater than 0, we'll get a command. So we'll have a string for the command is get valid command. Right? I know I'm going to get back a valid command here. So say, hey, if my command is equal to x plus, well, x plus takes my x tilt and adds 1 to it. Right? If it's not that, else if my command is equal to x minus, let's take my x tilt and take 1 away from it, minus minus. Right? If it's not that and it's not that, is it y plus or y minus? Right, so we'll do y plus, y plus, come on. That better work with me. Not a t, a y. Or y tilt plus plus. Sometimes copy paste isn't great here. Y minus, take our y tilt minus minus. Right? So those ones are pretty easy ones. Right? Just change our tilt by 1. Right? How about then else if my command is equal to thrusters? Right? Well, thrusters took my distance to surface plus equals 2. Right? Adds 2 to your distance. Plus equals 2. My goodness. This coffee at the gas station is extra caffeinated. I got a picture of it here because I thought it was funny. And this is cup number 2. Yeah, I was very excited. They finally opened the freeway so I can take Wixom Road to 96 instead of going all the way down to M5 and pass the gas station with extra caffeinated coffee. Good times. Because I was too lazy to wake up and make a pot at home. All right. Cool. So thrusters goes up by 2, right? And then else if my command is equal to self-destruct. Let's do self-destruct. Let's just call it self-destruct function here. Right? We'll just stub it out. Sure. Let's have a void self-destruct function. There. Now I've got a function. It's not going to return anything. We'll just do the self-destruct thing. We'll come back to it later. Right? I wrote a stub. my code will at least compile. It's not going to do anything yet, but now I don't get the red lines. Okay. If it's nothing, we don't really care, right? Because if you enter nothing, nothing happens. Sure. So all of these things will do something if you get a valid command. I know it's valid, so I know it will match one of these. When that's done, then I'm going to take my distance to the surface -1, because you gave me a valid command. Your distance goes down by 1. Now, we probably want to tell them what their tilts are and their distance, right, before we get the command. That might be useful to know, right? We haven't told them yet. So, hey, we could say you are distance from surface, units from the surface, and cout or x tilt is x tilt, and your y tilt is, I don't know if those mean anything here, but sure, why not? A y tilt and an end line. So we can output those values here. Right? Here's your tilts, here's your distance, enter a command. Sure. If you wanted this prompt to be in the valid command, we could pass x tilt and y tilt and distance to the get valid command, and it could do the prompt for me. And once we have variables, we can put them anywhere we want. You can give them to any function you want. You just need to say, hey, it's an argument. So if you want those values in here, define them as arguments here, or define them as parameters and give them as arguments. Right? Whatever is going to make sense, right? It will get the exact same job done, whether or not you output here or you output in the get valid command. Right? Either one works. That's okay. Right? We could even make this a function if you cared to, like output status. And then you could pass those things as stats. Should we do that? That sounds like fun. So let me show you a trick. I think this works. It's been a little while since I tried. So I've got those 2 lines highlighted here. So I'm going to right click and do I have the, I don't have the, oh, quick actions and refactorings. I want to extract function. So Visual Studio is written by developers who are lazy. Right? We want all the shortcuts we want. So this sort of thing where like, hey, I'd like this to be a function is pretty common. Our technical term for that is refactoring. We're changing the way things are organized without changing any behavior. Right? We're just changing the factor. Refactoring here. So I can extract function. Let's, I don't know what, display status, or what do we call that? Display status. Above the current function, right? Because we need to use it here. And it says, hey, I know you need an int, an int, and an int. Like it can detect that because we have 3 different variables already. It says, hey, would you like me to include those in your function? Yes, please. And now we get a function, display distance from display status, that takes an integer for display distance from surface, takes an integer for x tilt, takes an integer for y tilt. And then it even replaces it for us here. And if you're not comfortable with functions, this probably is crazy, and that's okay, right? We're still learning. We just talked about them on Monday. But the tool does a lot of this work for us here, because I'm all about shortcuts, right? So we could have written this by hand, or we could say, hey, tool, do this for me, please. I love when the tool does that for you. Now, it's not going to work every time. Like, if you like highlight these 3 lines and try and extract this function, it's going to be really confused, right? Like, extract function can't be completed. Unknown error. Like, it's not perfect, okay? It's what it is. So, so we can display the status. We can get a valid command. We can figure out what our commands are doing, take our distance down by 1, and then the loop comes back up to the top. Is our distance greater than 0? Okay, if it is, display the status. So at the end of this then, right, we can, how about we say display crash or land, right, given it needs the tilts, right? So an int for x tilt, or I would just give it x tilt, we go y tilt, right? If I give it x tilt and y tilt, we should be able to figure out whether or not we crashed or landed. So let's write another function. I'll just copy this one here and take this one out. Okay? We don't need the distance from surface one. We can say real quick then, so if my x tilt is equal to 0 and the y tilt is equal to 0, you can see out, you landed successfully. That's a lot of double letters in that word, my goodness. And if it's not that, right, my else then, we crashed. You crashed the $3 billion lander. Uh-oh. I don't know, something, right? Whatever you want us to say. right? You can either be like the Russians and crash your lander, or be like the Indians and land your lander on the south pole of the moon, which is super cool. You guys should all be more excited about space. It's okay if you're not. That's all right. Everybody has different interests. Okay. So sure, we can do that. Now the formatting's a little weird here. That's okay. So let me go to Edit, Advanced, Format Document. Okay, and now it fixes all my tabs for me, right? You don't need to do any of the tabbing yourself. Just go format the document. As long as you've got the right curly braces, it'll format it for you. Now, if your curly braces are screwed up, it has no clue because it bases everything off the curly braces. So that's all. Display, crash, or land. Did I do it wrong? Display. Oh, I display, crash, or I copy pasted and forgot to change the name. Okay. Again, this is probably a little bit excessive. We probably didn't need this many different functions. But we're just having some fun here. We're playing with functions, right? I could take these things as functions. Now I have nice names for them. So my whole main method here, for just looking at main, like this is usually where you start to figure out what a program does. You go to main and you see what main does. So you say, okay, get some random values, get the lander to the surface, jump play again. Like, well, that's not very, like, what happens when you get the lander to the surface, right? Let's go there. So again, you can scroll around, you can right click, and you can say go to definition is a good shortcut. It'll take you right there. Or you can pick in your little drop down list here, or you can just scroll up and down until you get lucky and find it. There's always lots of ways to do whatever you want to do, right? So, okay, so we can see, what does get lander to the surface do? Okay, well, it displays some status, it gets a valid command, does some stuff with the commands, self-destruct. Oh, we didn't finish self-destruct yet, so let's go there. All right, so what does self-destruct do? Well, we say entering self-destruct, or what did they say? Self-destruct sequence activated, I think. Self-destruct activated. Enter cancellation code. That's probably it, right? Sure. And maybe we have a string for the code. Cancellation code. There are two L's in that? I don't even know. Equals this. And then we're going to say as long as they did not give me that loop here, or did not give me the code. So as long as the cancellation code does not equal, and then we can put it in here, we can make it a constant. We're only using this once, so I don't feel too bad making it less literal here. What should the cancellation code be? I've bored you all to death, I'm sorry. Stop, okay? Sure. As long as it's not stop. And then we can see in the cancellation code. Okay? Literally all it does. It does not let them out of self-destruct until they give me the cancellation code. And maybe then we see out, self-destruct. Destruct aborted. Sure. Again, if you've not watched Star Trek, the whole bluffing thing with self-destruct is probably not as interesting here. But if you're a big nerd like me, you can blame my mother. I even went to Star Trek conventions as a kid. I enjoyed myself, and I had a Halloween costume where I dressed up as Data. I was super cool. I was cool as a kid. You guys are so mean. Man, wow. That's all right. That's okay. All right, so I think it's done. Now, I probably should have hit run more often and tested these things out as we were going, right? Done a little bit at a time. I apologize. So that's a little easier for you to figure out if something breaks or not when you test one thing at a time. And I got excited writing the code. So my apologies. So let's give it a run, see what it does. Oh, that's right, this window here. All right, we are 10 units from the surface here. We have tilt of 9 and 9. I think they're probably always going to be the same. Oops. Let's do this. Hang on one sec. I want to not do the srand thing here. Functions run really, really, really fast. Code runs really, really fast. When you seed, this time here is based on the millisecond clock time. And I can essentially call the same function twice, like within the same millisecond. Yeah, I'm getting the same tilt every time. So because I'm reseeding it, it's restarting the sequence back at the exact same millisecond here. So this was a mistake to do here, because I'm going to get the exact same values every time, because it's really quick.
SRAM time, and then just put zeros and null.
That would probably give you the same value every time as well. Different ones? Cool. If it works, it works.
Maybe I.
Okay. I mean, it doesn't really, I just like different numbers. So I'm just going to put it here in main, so it seeds it one time rather than every time I call for a random value. So this should give me different numbers each time because I'm not reseeding when I start. There we go. Okay, so now I've got 5 and 4. So do you want to try and crash this thing, or do you want to try and land it? Land it. Okay, so let's do x minus, x minus, x minus, x minus, x minus, y minus, y minus, y minus, y minus. And then we're 1 unit from the surface. We can just do, let's do self-destruct, right? Why not? Self-destruct. Self-destruct sequence activated. Enter the cancellation code. Oh, it's not working. Stop. Self-destruct aborted. You landed successfully. Do you want to play again? Yeah. All right, let's crash it. Nothing. 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 Oh, you should give it some commands that are not valid, right? It just doesn't let me do anything here. Nothing. 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 You crashed the $3 billion lander. Uh-oh. You'll play again? No. Very exciting. Very, very exciting. You guys are thrilled. Now, I can get a screenshot here too, which is fun. It doesn't have to have everything in here, but if we wanted to put a lot of the stuff in, we could. So let's go commit and push this here. GitHub, come on. Git, type. For 150, here's project 1. And push, and view on GitHub. Now, I've got this README file here, but you probably don't want the project 1 screenshot here. You probably want a screenshot here in project 1. That'd be nice, right? So I'm going to cheat a little bit and use the web browser here. I'm going to add a file here called readme.md. Again, this was not, you didn't have to do it because you've got your own repository for each project here. I don't have that for mine because I'm putting everything in one, so you don't have 50 different links to look at. But just a different thing. So I'll make a commit here and add a README file. Come on, refresh. There it goes. So if you put a README file in, GitHub's like, oh, hey, you probably want to show this README file. It's just it's a convention here that GitHub follows. So if there's a README file, it shows it to you. It's a pretty smart convention, right? So now I can see my screenshot for this project here, right, in this folder, rather than the README file at the repository level. So you can put README files anywhere you want, right? And if it finds one, it will show it. I just thought that was fun. Not helpful for you at all because you don't need them. Just a fun tidbit there. Okay. So I guess the fun tidbit where it might be useful, if you want to build out a portfolio on GitHub and show off some of the work that you've done, you probably don't want 50 different repositories. You could, or you could just have one portfolio repository, and each project that you want to show off, you can have its own README file or something like that, or you got lots of choices. People organize things all the time, but generally having a public GitHub repository with something to show off is maybe not required, but that's a helpful thing to do when you're applying for jobs or internships. Like, here's some of the stuff I've done. Take a look and see. Right? I don't know if people are actually going to spend the time to look deeply at it, but when I was hiring people, I'd go click some links and poke around. Not more than 5 minutes, but I'd poke around just to see what they had. And if they didn't have one, I'd be like, oh, okay, it's not the end of the world. But it was cool if they did. Okay? Not that the games and things we're building, these silly little projects are very interesting, but yeah, if you want, you can start having them, showing them off. So, all right. Project 1, questions, thoughts, concerns? Okay, again, this was using functions because we've talked about functions. Functions are fun. You didn't have to at all, right? We didn't gain anything by using functions aside from like saving one line of code with this random number generator. Everything else, like, we just do one time. Right? I don't think we're repeating any of these things here. Just a fun way to kind of break it up into different steps. Okay? All right, awesome. So let's go back to my other project. Close this one down. Close the solution to, there we go. There we go, functions. That's the menu I wanted. And then we pull up the Zybooks here, try and keep us on track. Oh, that's the wrong one here. And we got to talk about the next project too as well. So we're doing good, right? We got a little bit of time. Oops, I did not want an extra 0 there. Click. There it goes. All right, so we've done printing functions, math functions, branches, loops, unit testing functions. So this is fun. The idea with testing functions, right, is Does it do what it's supposed to do? Right? Testing an entire program, sure. Does the program do what it's supposed to do? That's a little bigger, a little harder to tackle sometimes. Testing one function at a time is a little easier. It's very focused. Does it do this one specific thing? Right? The general rule of thumb is functions should do one thing. If it's doing 5 things, you should have 5 different functions. Now, sometimes it's a little excessive, but that's a pretty good goal to get to. Like, hey, have it do one thing. If it's doing 5 things, just make 5 different functions. That's, it's not the end of the world. And it breaks things up into nice little units here. And then, goodness, sorry. What you can do is you can test that function to make sure it does what it's supposed to do without having to hit run and type in a bunch of stuff and see some input and see some output. Because it's a function, right? I can write code that uses it and checks to see if it's doing what it's supposed to do. Now, I'm not the biggest fan of how they test their conversions here. Like, they're just looking through with this assert. I'm not a fan of this. Once we get to classes, I will show you better testing things that uses this idea of the test harness. And there's some tools in Visual Studio that automate tests for us, which are super cool. I'll go nerd off about that when we get there. I think using asserts here are really ugly. Just a personal preference here. Excuse me. So asserting, sure. So we can do that. So we have none of these really like just do a simple calculation here. Let's see. Let's do a silly function here. So let's add a integer for get largest number. Largest number here. It takes an int for first number and an int for second number. Okay. So we're going to return the larger the larger number. I can say if my first number is bigger than my second number, I can return the first number. Otherwise, I'm going to return the second number. Now, this is going to look a little weird here. Again, this is a shortcut. Remember, once you hit a return statement, the function stops. So if this line runs, nothing else executes in the function. Normally, if you have an if, you might have an else. The else is redundant because if this is not true, the rest of the code is running anyway. So it's just a very quick way, right? I don't need to put an else because if this doesn't run, we know this is going to happen. If it does run, it stops. Usually the else prevents the other branch from running, but because the return is stopping the other part from running, I don't need to type else and put in some curly braces. And just a lazy shortcut. Else is redundant. Redundant? Sure. You can have it in, it's not going to hurt anything, but you don't need it there. And again, I'm fond of not doing things we don't need to do. Okay, so if you wanted to test if this works here then, right, I can say assert that my get largest number of 10 and 20 is equal to 20. What do we have to add here? Assert, where does that come from? The include CAssert. Sure, why not? Let's go include that. Okay, so we can give that a run. We don't see anything happening here. It doesn't look like anything happens. But if it is not true, right? If we assert that this and it does not give me back a true result here, now we're going to see something. We crashed our program. This is why I hate asserts, right? Assertion failed. Get largest number 10 of 20 equals 10. Abort has been called by assert. Ugh. That's really ugly. Like, that's a hard stop. So, I mean, maybe for some things, this is a good check to have. Like, you don't want this program to run if something's out of whack. Sure. Not my favorite approach, though. Right? There's other tools and techniques and things we can do for this. And then we're not going to have to put code in our main function or somewhere else that does this here. So Eric doesn't like these. It's always fun to talk about yourself in third person. I don't know why. It's just something fun about it here. Like your royalty, right? The queen talks about oh no, she doesn't anymore. That was always my example for so long. That's so sad. Does the king talk about himself in third person? No? Okay. I don't know. It's not worth keeping up with British politics. Not anymore. Okay, so you can add asserts. So, and that idea is if you know what your function's supposed to do, you can give it an input, assert that you get the correct output. Right? That should work because we wrote the code, we know what it's supposed to do. If it doesn't give you something, then you messed something up somewhere. That's okay. We can go fix it. So the sort of idea is we're testing things. A lot of times we call them edge cases. Like I expect things to work pretty well most of the time, but that's in this edge case, you might get some really weird input. Right? Who knows what the user is going to throw at us. So being aware of the edge cases and handling edge cases is important. You can go a little nuts here testing all the different crazy things users can give us. So at some point, there's some diminishing returns to, oh, well, do I want to test all the different things they can enter? There's a funny shirt here. I don't think I own it. I think I wished for Christmas or Hanukkah and didn't get it, which was sad, but it's QA engineer, bar shirt. This is one of my favorite shirts. One of these times I'm going to get it here. Let's see. Is that the picture? So a QA, quality assurance, people who do their job as testing, making sure there's quality, assuring quality of your software. Walks into a bar, they order a beer. They order 9E99 beers. They order NaN or not a number beers. They order, this is one more than the max integer. Right? This is, when we talk about max integer, 2,147,483,648 beers. They order, this is a string drop table beers. This is a SQL injection attack, this sort of thing. They get kicked out of the bar. You're going to get some weird stuff from users. Who knows what it is? So quality assurance folks are generally the kind of people who like picking things apart and trying to throw weird things at you to see if they can break it. The joke in the industry is quality assurance engineers are trying to get the software engineers fired because they write so many bugs, and software engineers are trying to prove that we don't need to hire quality assurance analysts, engineers, because they never find any bugs. It's not actually a competition, but like that's sort of the joke here, right? That's the goal. You don't want them to find bugs, and they want to find all the bugs, right? So just sort of a fun thing here. So testing your code is nice. And depending on your organization, they've got different ways and policies and procedures around tests and all sorts of fun stuff. I'll talk more about tests when we get to classes, because at that point, tests make a lot more sense to me. At this level of functions, I think they're a little silly, and I just think asserts are stupid. So, but they exist, and they're fun. So there's the section on it. How functions work, sure. Common errors. I didn't turn on the labs, I'm sorry. I forgot to turn on the labs here. These labs are good for functions. Swapping variables, that's a good one. Flipping a coin is really good. I like flipping a coin. Sorting a vector. This one's a little weird here. So we haven't really got to vectors. I don't know why they're giving this one yet. We didn't get there yet. This one's a little weird. I'm going to leave this one hidden. Don't worry about it. And word frequencies. This one's a fun one here. Word frequencies. Because remember, we have all those cool string functions we can do with strings. And we can get substrings, and we can do all sorts of fun stuff there. Is this using a vector again? Stupid. All right, never mind then. Hide that one. Why did they put these out of order? Fibonacci, does that one use a vector? No, okay, so we're going to keep this one. Fibonacci is a fantastic sequence. Familiar with Fibonacci? You probably talked about it in math class at some point. Okay, couple head bobs, awesome. So, okay. No, you didn't talk about it in math? Oh, your math teacher's boring. Fibonacci's so fun. All right, so I think we got those ones there then. This one didn't use a vector, right? I just want to make sure we didn't use vectors. Yeah. Okay. Good there. How about this one? Swapping. Okay, that's fine. That's fine. We'll get to that. All right, so how functions work. This one's fun, right? This stack idea. I think I showed you the call stack briefly. You can see it when you run in debug mode. They're going to give you some more examples of that. And the other interesting thing here is it has to track all of the variables used at each function here. So when we go back, let's open up project 1 again, because that was fun. Close the solution down. We'll open up project 1. We had a function that called a function that called a function. That's perfectly fine, right? Anything can call. Main is a function, and main was calling functions. So we did that. Oh, I was going to talk about the lab. You guys didn't remind me. I had one fun thing in the lab. Let me show you that one thing. This is making me think of it here. CIS 50, 3. I think I put it all in lab 0 because I was lazy. Let's see. Oh, this is in my Chernesky repo here. That's right, or org. There it goes. So, no, did I do it in lab 1? Maybe I did it in lab 1. 50. Can't type, friends. Lab 0. We're getting there. Yes, here it is. So lab 1. So when we were talking about the lab, this idea of taking functions and making all of our things into those. I can hide that. Okay, zoom that in a little bit. So we looked at a couple of these: get shape, get size, print triangle. These were some basic ones, like one piece at a time here. Printing of a rectangle needs a length and a width, right? So the length is essentially every row, and the width is every column. Or however you wanted to define it, right? You could flip-flop them, it doesn't matter. Right? But this needs a length and a width. For a square, oh, I showed it too fast, that's right. You just need the size. Printing a square is printing a rectangle of length and width being the same. So your function can call another function, so you don't need to repeat code, right? That's one of the goals of functions here, is avoid that repeating code. So your print square can just call print rectangle, given its length and width as its individual size. That was the shortcut here. So your function can call a function. That was the part I wanted to show because I think that's clever. Right? Okay. That was that piece. So in the project, when we looked at project 1, oh goodness, it gave me a header file. Those are gross. Okay, we don't need that. So our function was calling functions. So we had somewhere in here, display status. So I'm going to put a breakpoint in display status and run this with debug mode. So when I display the status, right, I was at main, line 103. Then I got to get lander to surface at line 65, and I can click there. It will take me to line 65, which is nice. Right? It'll take you around here. When I click this one here, I'm seeing the value of the variables here. So what has to happen when you call a function and you pass arguments? That function has a copy of those variables in memory. So we're slightly less memory efficient here because I now have the x and y tilts in main at -6 and +6. I have them in my get lander to surface at -6 and 6 in a distance. And then in my display status, I also have an x and y tilt variable. Notice they get these garbage values to start. As soon as we run one line here, now they have values. It just takes it just a second. Like they're not technically initialized until you get into the function. I don't know why, but they'll look weird until you get in. So now we can see the value. So we actually have 3 copies of these, which is a little bit sad, but again, in integers, 4 bytes. So, and we've got gazillions of them, right? That's a technical term, gazillions, I'm sure. So we're not worried about it. Not a big deal here. But if you're doing things a million times, right, and having millions of variables here, it can get a little messy. We'll talk about ways to get around that later, but it does keep track of them. And the interesting piece here is if we run this, I'm going to hit continue, and let's do x minus here. Oops, x minus, there we go. Now, step 1, I can see it's -7 and 6 here. When I get lander to the surface, it's -7 and 6 here. In main, it's still -6. When you pass an integer here, so in main, I set x tilt and y tilt to values here, and I passed them to get lander to surface. When you pass integers, you're not passing that location in memory. We're not saying go read the value out of this location in memory, right? When we ask for a variable, your C++ says, hey, operating system, give me a place to store this, and it knows that memory address. Somewhere out in your memory bank, somewhere, we can store value. When you pass it, we don't pass the memory address, we're passing the value. We're passing by value, we're passing a copy of the value. So now those 2 numbers are different. So get lander to surface stores x and y over here, and main stores x and y over here in memory. They're distinct variables now. And again, that's why it takes up extra space, because I've passed a copy of it. So as it gets modified in get lander to surface, it's not modifying them in main, because main knows they're over here, get lander to surface knows they're over here. So you can run into some problems here. You got to be a little careful when you're passing values around. That's the pin button, there we go. So you gotta be a little careful. So some common errors with functions. A common error is to copy paste and not change them. Yeah, I do that a lot. So we love copy pasting. It's a great shortcut. You just gotta be careful, right? Modify them all. This is, hey, they use awful, awful, awful function names. Celtifa, like the number 2, like you're not texting this. You're not saving any typing here. Like IntelliSense will type code for you. So convert Celsius to Fahrenheit or something. I mean, like give it a nice name here at least. I guess it's hard to spell Fahrenheit. I would have a hard time spelling it, but anyway, be careful with changing what you modify, right? So there's an error over here because we copy pasted and didn't change something over here from this original version. Again, go look at the iBooks, you can figure it out, but they are still returning a Fahrenheit. I guess I say you could figure it out yourself when I told you, sorry. So they fixed the math right, but you're giving back the wrong value here. So it's easy to miss that sort of thing is all. Yeah, other functions, awesome. So if you don't want to pass a copy, you can pass the reference here. So generally we pass things by value, pass a copy of it here. If you want to give them the memory address, you can pass by reference. This gets kind of into the weeds of C++, and this is one of the reasons it's a weird language to start with, because it does a lot of interesting things. So you've got an option here. So, and they kind of take you through what that looks like. So if you want someone to give you the memory address and use the same reference here, you add in the ampersand character. So you say, hey, I want an integer reference here, not a regular integer. I want your original copy. So if we go back and change that here in our function, so if we want get landed to the surface, if you give me the reference to an x and y tilt here, all I have to do is add it in the function definition here. Right? Nothing has to change over here. Now when I run it in debug mode, let me just continue past that first step here. I'll just change, how about x minus? X minus, I did the wrong order here. So now I see, let me step one more. They are 2 and 0, 2 and 0, 2 and 0. Because I've not given them a copy, I've given them, here's where it is in memory. So it's actually more efficient at this point as well. Right? I didn't have to make a copy, I don't have to store more numbers in memory. So I said, this is where they exist, go get them here. So it's nice. Sometimes you want that to happen, sometimes you don't want that to happen. Again, as we get further into programming, we'll talk more about that. It might seem weird that you don't want someone to change your values, but there's good reasons for that at some point here. So passing things by reference versus by value is a way to do that. The other cool thing that lets us do is, I don't know if we noticed here, but when you have a function that returns something, right, you can only return one thing. Right? You can't return command and like then also say, hey, return 10 or have another value you wanted to return, right? You only get to return one thing. So if you pass someone a argument by reference, they can set the value there and then it will stay changed because you've given them a reference to your variable. So they can change it, essentially giving you another value. Instead of just returning one thing, it can set some other values and it's like returning more than one thing. So a lot of times we use that as shortcuts to say, hey, like this one here, I want to go and set a bunch of things here. So I'm going to compute the change and I'll tell you the number of quarters, number of dimes, number of nickels, number of pennies. Because I can't return a bunch of different numbers. Later we can, but we'll pretend like we can't, right? So I can go set how many quarters, how many dimes, how many nickels, how many pennies that change was here because you gave me a bunch of variables. So kind of a weird shortcut workaround here for doing that. There's that one. We are almost out of time. My goodness, I'm sorry. So let's talk about the next project. We're going to use lots of functions. So do you want to wait or do you want it now? We can wait till Monday. So I heard one vote for wait till Monday, one vote for now. I need a tiebreaker. Should we flip a coin? Hang on. Okay, here. I've got this. Got a solution for you. I have 20-sided die here. So 1 to 10, we'll do it now. 11 to 20, we'll do it on Monday. Is that okay? All right, you all agreed to leave your fate to the die? All right, we're rolling now. Anyone want to roll it? Here. Go ahead and give it a roll. All right, so we're going to wait till Monday. Critical success. All right, So I'll see you folks on Monday. It's okay if we push things back a little bit. Won't be a big deal. So yeah. Yeah, I'll finish up the recording, and then I'll come figure out what's going on there. All right, folks, have a good one.